On Friday, we're going to be doing a lab in class. Usually when we do labs, we always kind of brainstorm um, after seeing the phenomena of things we could change about it to see if there's any effect. And then we write our purpose statement and procedure and data tables and everything like that. We don't have time to do that on Friday and get our data. So I'm really hoping that you will have this all ready to go. You'll have your brainstorming done, you'll have your purpose statement done, you have your procedure done, your tables done, everything so that when you come in class on Friday, you'll be ready to take data. So here's the phenomena. First of all, this is called a simple pendulum. It's called simple pendulum because most of the mass is concentrated down here. This is called the pendulum bob. And there's either a string or a rope or a wire or whatever that's supporting the pendulum bob. And one thing I noticed about this pendulum bob is that it takes a certain amount of time for it to make a complete vibration of to and fro motion, back and forth. That's called a period. So the time it takes for it to go to and fro, one oscillation is called a period. You can measure that period from any point. So I don't have to start necessarily here. I could start right at here and then stop here. Or I could start the time here and stop here. So that's one complete oscillation called the period. So I want you to brainstorm what are some things that you could change about this setup that might affect the time of vibration called the period. So pause the video and do a brainstorming session real quick. Usually in past years when students brainstorm, these are kind of what most students kind of come up with. They say something about, you know, how far this thing falls, so like the drop height. So that would be measured from here to here, this drop height here. So they say something about the drop height. They say something about the length of this. Perhaps the changing the length of this might affect the the time of vibration. They say changing the mass of Bob here might change the time for vibration. Sometimes we have students say something about the gravitational field strength. So if you go different places on the Earth, there's different gravitational field strengths. Or if you go to the moon or Mars or whatever, there'd be a different gravitational field strength, and maybe that would affect the time of vibration. Sometimes students will say the shape of this, so whether it's square, round, whatever. The density of the bob at the bottom. Sometimes students will say the density of the air. So imagine if this was water or honey or oil that was swinging through. Maybe that would affect the time. And then sometimes students will mention something about the friction up at the pivot point right there, and that will affect the time. Then we will start talking about things that we can actually measure. And we can measure these three here. We can easily change the drop height, so we could pull it back this far, the drop height, or pull it back further, the drop height, and so on. We can totally change that. We can change the length of the pendulum, simple pendulum, pretty easily. And we can change the mass of the bob by using the masses in the drawer, the second drawer. These other ones, they're kind of good ideas. Some of them we can't actually test, and some of them are going to help us form our procedure. So, for instance, the gravitational field strength totally makes sense, but I can't actually change it. We're going to agree to do it here in the room so that we're all speaking the same language when we whiteboard. The shape of the bob, we're going to use the masses in the second drawer down, and they're all cylinders, so we're going to do it the same way, so we're speaking the same language. That's another good idea, but I don't think we really have time to do that, and so we're just going to make sure we do it the same way. For the density of the bob, all those masses are made out of the same type of material, so we're going to do it the same way. Another neat one to try would be if we could do it in air or oil and stuff like that, but we just don't have the time for it, so we're going to agree to do it here in the room, all through air, all the same way. And then the friction at the pivot point, another thing that would be kind of interesting to check, but we just don't have time to do it. So we're going to make sure we do it all the same way so that when we whiteboard, we're speaking the same language. Okay, so the next step is we need to name this lab, write a purpose statement and a procedure and data tables and stuff. Okay, so we're calling this lab the Simple Pendulum Lab, and the purpose is to graphically and mathematically model the relationships between the period of vibration of a simple pendulum and the drop height, and the relationship between the period of vibration and the length, and the relationship between the period of vibration and the mass. Now, it's really important that when we do this lab, you get 6 data points for each of these 3. Now, this is a more complicated lab than we've done so far. So this one, you need to really be on your A game. You need to be thinking in advance how to do this lab in such a way to reduce error, okay? So, so far we've been kind of loosey-goosey. You make mistakes, that's all right. We've kind of a little bit forgiven you in the whiteboarding. But you need to understand that if you consistently make mistakes, that tells me that you're not putting a lot of time into making a good lab procedure and you're not really thinking about it, and it will start to hurt your grade. So you need to really think about this one. This one's really easy to make mistakes on if you're not really thinking about what you're doing before you start the lab. For example, think about what we've learned from the tube lab. I like to call that lab the fair test lab. You can only change one variable at a time. So when you're doing this lab, it's really important you realize that you can only change one variable at a time. That's one thing. So the second thing is, do you remember the one worksheet where you plotted data and the data was kind of clustered together and you couldn't really tell if it was top opening, side opening, or linear? Well, this is going to be one of those labs where it's really easy to cluster all your data in one spot. Unless you're thinking, you have to be thinking before you even do the lab. If you start the lab without actually thinking it through, you're probably going to cluster your data. So you have to really think it through. So for this, you want to make sure you have a good spread in data. And you have to make sure that it's a fair test, okay? So let's first of all talk about a fair test. So for the drop height, that means that you need to make sure that the mass is constant, and you should record whatever that mass is, and you should make sure that the length is constant, and so you should record whatever that length is. Now, what does that mean in terms of the lab? Well, when you're doing the drop height, what you're going to do is at the bottom here, and you're always measuring the drop height from the center here to the center of wherever you pull it up to. And so really, you're just simply measuring this distance here. This will be the drop height, h. So for that lab, you just need to make sure the mass is constant and the length. And by the way, the length goes from the bottom of the bar here, because that's where it's swinging about, the bottom of the bar, to the middle of the mass. Well, this is actually a pretty easy lab to do. Keep the mass constant, don't change it, and don't change the length of the pendulum. So that's pretty simple. All you're going to be doing is changing the drop heights. So this is almost a foolproof one. So I would recommend starting with this one first, because you don't have to be worrying too much about making mistakes. As far as measuring the height, what I'm going to give you over here is a stand, and the stand's going to have a little pointer bar. And this pointer bar, you can point right at the center of this wherever you pull it up to, and then you can move this pointer bar to over here when it's hanging straight down and just measure the distance between the pointer bar and the center. So that one's pretty easy to do, and then you can get 6 data points. Now we should talk about measuring the time. Sometimes it's really easy to measure the time of one vibration with the stopwatch. I mean, that's really kind of a slow vibration. That's really easy to do. I don't have to worry about, making timing errors or anything. But sometimes it's going to be swinging so fast when you're doing this lab that it's going to be really difficult to get the time for just one vibration. You'll have too much human error. And human error is not something that's good for engineering students or physics students. So in other words, it's not acceptable. So I would recommend that if it's swinging really fast and it's, going to lead to big errors, I would let it swing for maybe 3, 4, 5 vibrations, time it for those 5 vibrations, and then divide by 5 to figure out the time for one vibration. All right, so that one's a pretty easy lab. don't forget to record your constant mass and your constant length. Okay, the next experiment, have to be fair, so for the length, you got to keep your mass constant, and you got to keep your drop height constant. So what you're going to be doing in this part of the lab is there's a little clamp up here, and you can release the clamp and let string out or let string in to either shorten your pendulum or to make it longer. Again, you measure the length of the pendulum from the bottom of the bar to the center of the mass. The mass, that's pretty easy. You just keep the same mass on there the entire time. But for the drop height, you have to make sure that drop height is constant. So whatever you choose it to be, it's your choice, you have to keep it the same no matter what, whenever you change the length of this. So in other words, that's a little bit challenging. You got to be careful there. I put a little star next to that because that one you got to be worried about. You could accidentally mess that up where the drop height is the same. On top of that, you remember how we said you want a good spread in data? This one over here is not a big deal. You can definitely get lots of different drop heights. That's easy. This one's harder though, because let's say you start with a really long pendulum and then you start getting shorter and shorter and shorter. Keeping your drop height fixed at a certain amount, if you started really long and you said this is your drop height, well, you can't get any shorter of a pendulum than this amount if you pull it all the way up, right? So what I would recommend for this one here to get a good spread in data is I would start with a short pendulum first and then make it longer and longer. So start with short pendulum. And the reason for that is if you start with a really short pendulum, if you pull it all the way so it's, you know, horizontal here when you drop the thing and it's only that long, well, that could be your drop height then. And you keep that drop height the same all the way down. So by starting with a short pendulum, you could figure out what your drop height is and just keep that constant. All right, and then the last one for the mass. It's really easy to get lots and lots of different masses because we have a second drawer filled with masses, and I'm going to show you what that second drawer looks like in a little bit. So that's not a big deal. You can get a good spread of data. But the problem is, think about the things that have to be constant. Well, for this one, you have to keep your length constant, and you have to keep your drop height constant. Well, just like in the last one, you got to be really careful and make sure that drop height is kept constant. So I'm putting a little star next to that. But this last one's even more challenging than part B here because let's say here's my one mass and I've got a certain length there. I'm going to keep the length constant. If I were to put a bigger mass on here, its center is now down here, and now the length is not the same as what it was before because you're not measuring the length from here to where the hook is. You're measuring from here to the center. So I've just changed, by putting a different mass on here, I just changed the length, and that's not allowed. So what I have to do is put my mass on here and then unscrew this and decrease the length of the string to pull the center back up to what the center was before, and then clamp it back down. So this one is super challenging because every time you put a different mass on there, you're going to be changing length. And you have to make sure that your height doesn't change, your drop height doesn't change. So don't forget, for every one of these, you need 6 data points. And you need to make sure that you recorded what your constants were. Actually say how many kilograms, what was this length in meters, what was this drop height in meters, what was this in kilograms, what was this length in meters, what was this drop height in meters, okay? All right, so the next thing you need to do is write 3 data tables. So pause the video and go ahead and write 3 data tables. Okay, so your data tables should look like this. So this is the first part of the lab. This is what I recommend doing this one first because it'll be the easiest one. less likely to make mistakes. You'll be changing the drop height. Again, you're measuring the drop height from the center of your mass until your pointer bar. You get to change this pointer bar to be whatever you want, okay? Don't forget to record whatever your mass was. Don't forget to record the length. The length goes from the bottom of this bar here to the center of your mass. Again, sometimes it'll be vibrating so fast, you want to make sure you eliminate, or you want to try to reduce, I shouldn't say eliminate, try to reduce human error and your timing measurements with the stopwatch. So if it's going really fast, maybe you want to do 5 vibrations or 10 vibrations or 3 vibrations, whatever you deem appropriate. Let's say it's 5. You would time for 5 vibrations, divide by 5, and you'd record that time. Make sure you have 6 data points. For the next part of the lab, you're going to be changing the length. Again, make a note to yourself that I'd recommend starting with a small length first and get progressively bigger, because you need to make sure you have a constant drop height. And by starting with that small length, you can make your drop height be that small length. You want a big spread in data. Make sure you record your constant mass, make sure you record your constant drop height. And again, you need 6 data points. Again, if it's vibrating really quickly, you got to reduce uncertainty as much as possible. So maybe do 5 vibrations or whatever. If it's really slowly, you don't need to do 10 vibrations or whatever. You could probably get it in 1 or 2 vibrations. And then finally, you got to be really careful for this last one, because when you change the mass, you're also changing the length. And so you're going to have to readjust this every time you put a different mass on there to make sure the length is constant. So make sure you record that constant length, and also the drop height. Just like in this one, the drop height has to be a constant value. It's really easy to get lots of different masses because there's lots of different masses in second drawer, which I'm going to show you immediately after this. Okay. What I'd like you to do now is I would like you to pause the video and write out your procedure. Especially for these two, you have to really be careful that you write some good procedure steps so you don't make any mistakes. And then continue with the video, and you can see how the lab setup looks like, and you can see what's in your second drawer. When you come in on Friday, then you'll be able to get right in the lab, get your 6 data points for each of these, so a total of 18 data points. And we should be able to then graph it and maybe linearize it over the weekend and then present it on Monday. Okay. So this is what your lab setup will look like. You'll need a stopwatch, and you'll need a meter stick, and you'll have this pointing bar that will help you measure the height, and you'll have your pendulum bob. Now the masses, because they're part of the lab, you're going to be changing the mass of the bob. The masses are located in the second drawer there. Right here they are. Okay, and you don't have to mass them because it tells you what the mass is. So this says 200 grams on top, and you're just going to have to convert that into kilograms. Anyway, so for the part of the lab where you're changing the drop height, you'll measure the drop height between your pointing bar, which you can change that to whatever you want it to be. You'll measure the drop height between there and the center of your pendulum bob. So measure the difference between here and up to here. And then you'll be able to pull this back to the same height as your pointer. And maybe. So I can set the pointer pointing right at the center of my pendulum bob, and then I can time it as it swings back and forth. Now when it swings back and forth, since it swings kind of fast, you might want to do more than 1 vibration, maybe 2 or 3 vibrations, or maybe even 10 vibrations, and time for those 10 vibrations or 5 vibrations, whatever you decide that's appropriate. And then take your number of the time divided by the number of vibrations to get the time for just 1 vibration. And to get a different height, you'll just simply change your pointing bar, and then you can get your new height. Got to get 6 data points for this. To measure the length of the pendulum, you will measure between right up here to the center of your mass of your bob. So that distance, that will be your length of your pendulum. And if you want bigger lengths, all you have to do is you can rotate this around so it goes over the floor like this. And there's string here, so you can release the clamp a little bit and you can let it go out to change the lengths. And you can even move the pointing bar and put it on the floor to measure your drop height. Okay, so it is kind of important. You have to be careful. For the drop height, this is a pretty easy lab. Make sure you record your constants of mass and whatever your length was, and you'll just change the drop heights. But when you're doing the other labs, like for instance, when you're changing the length of the pendulum, you have to keep your drop height the same, constant throughout the lab, and you got to keep your mass constant. Well, the mass is pretty easy. That's not hard. But the drop height you have to make sure is constant. So I recommend that you start with your shortest pendulum possible, whatever you want it to be. Let's say it's in here. That means your drop height really can't be any more than that distance. So it's really important you start with the shortest pendulum length and you get longer and longer. That way, whatever your drop height is, you can keep it constant all the way down. And don't forget to record the constants for that lab too, which will be your mass and whatever your drop height is. And then finally, for the last part of the lab, when you're figuring out what the relationship is between the period and the mass, you got to be careful with that one, because you got to keep your length constant and you got to keep your drop height constant. Well, if you put a different mass on here, let's say this one, notice the center of this mass is much lower. Well, that's going to change your length, and so you're going to have to adjust the length a little bit, because you got to keep the length constant, and of course you got to keep the drop height constant as well. So just keep that stuff in mind. Again, record your constants for the last one with the mass. Make sure you record your constant length and your constant drop height.